In this video, I'm going to demonstrate how to build a model to control a gaming environment using brain-computer interface. As you can see, I wear it right now, and this device can collect the signals from the brain waves, and I can train the machine learning model to control various environments. And as an example, I will show how to control game environment Unity. This device that I use, it's commercially built from Emotive company, but you can pretty much use any device that provide you with open API. And the first step would be to collect the signals. As you can see on the right-hand side, I'm running currently the program that I wrote in Node.js, and I'm using um, API provided by Emotive, which called Cortex. And using this Cortex library, I'm currently intercepting signal from the electrodes and pushing the signal in a Google PubSub. So I create a Google PubSub, and currently, when I'm literally talking and thinking, all my signals collected and pushed to the PubSub using this Node.js script running on my laptop. The PubSub is pulled by Dataflow. I have a Dataflow that actually read the data from PubSub topic and populate BigQuery table. So in the BigQuery table, let's query this table. In one of the table, I keep the raw data, which is basically exactly the same data that you see on the right-hand side. It's collect data from on my alpha, beta, and gamma rhythms. It provide a timestamp. You can see the whole data and the data that I'm correcting right now. And also it provides some additional information like a gyro. So basically it's sensitive if I move my head, and I can use this information to filter the signal. So I have another data flow that actually take this table and clean it a little bit and create another one, another simple table with just electroencephalography data like this. And also it has the annotation that associated with this. There's annotation used to train the model. It's basically annotation that really relevant to the mental command that I'm actually thinking during the time I collect the data. And those annotated data is used to build the model. And I use BQML model to train the algorithm and be able to recognize when I'm thinking about certain activity. For example, when I'm thinking about pushing mouse left, pushing mouse right, jump, or some other things, also shooting. So it's basically a mental command that I'm used to control the gaming environment. And then I have another source, another code, Node.js code, that actually control the gaming environment that I will show in the next demo. Now the question is, how would I collect those raw data, and what's the process of annotating of the data? For that, I'm using Emotive BCI graphical user interface that provides me with a simple UI to train basically collect my data for simple mental activities. Like as you can see, one of the type of activity can be push if I'm thinking about pushing object or pulling object. Also, I'm be thinking about pushing its left or the right, and I also can add the more command if I need to. So let's collect signals when I'm thinking about pushing object to the left. So basically we use about a second. Let's start thinking about, now I kind of thinking about pushing the mouse to the left, and the signal from the device will be collected. Now it typically takes about 10 seconds, so I can accept or I can reject a train. Let's say we accept that. So now this data being stored, And let's say I would like to train, not actually train, but collect the data for the mental command to push mouse to the right. So let's do that. Now we start thinking about pushing to the right, and we'll collect time series from the device and accepting this profile. So far, we're collecting the data from the device, and this interface is basically show you kind of graphical representation of your data. At the same time, would like to grab those data and push to the pub subtopic in the Google platform, and then use the pub subtopic as a source for my machine learning model. Um, so what I did, I basically create a Node.js script, which is using BCI library, which called Cortex. And in this library, I basically intercept the data now from the device. It's very simple code. And then I publish those data. I have a function publish to my topic. So basically, I use Node.js API to push those data. Uh, let's run the script, my data from the device, and I basically publish it those messages. So as you can see, it's taken in real time. So it basically take about 10 measures per second. So now those data go to the PubSub, and then from the PubSub, it get pulled by the data flow. So I create a big data flow that basically reads from the PubSub topic and to perform some data transformation and cleaning and store it. So I have another script um, that basically query this model. Right? So I use a BigQuery client, and within this BigQuery client, I formulate the query, and I send this query to the BQML model, and I grab it back and the prediction value. So based on those written, trained BQML model tell me what I'm thinking of. Am I thinking of pushing my mouse left or right, and so on. So let's see how it will train. If you can see, this basically show us the duration that I spent to train the model and how well it's actually predict. So I basically trained this model for several mental activity when I'm thinking about jumping, moving left, moving right, or shooting. Because essentially I would like to control my game, and I would like to control activity like moving my actor left, moving my actor right, let my actor jump, or use the weapon. So that's the model. Now, so basically this model will call to BQML, and then based on what I'm thinking of, it send a command. Obviously, I'm talking right now, so the command is not relevant. So basically, it tells that I'm thinking about left or other, which makes sense because right now I'm looking on the kind of from the left side, so my eyes and a little bit tilted, which send a signal. And let's think about something else. And those commands is used to control the environment in my game, which is I'm going to demonstrate in a second. Now I can quickly demonstrate how you can use this train model to operate brain-computer interface. As you can see, I train it for very simple commands like push left, push right. Other means look around, jump, and some other things. Currently, I run my script and I prepare this gaming environment Unity. Let's start and see how it goes. Let's see how I will be able to operate this avatar. Obviously, that you have certain discipline to clearly thinking about the commands and actions. Well, and obviously I'm lost. So now, as you can see, the environment start automatically operate, but because I'm speaking, the type of command probably not the relevant. Um, but essentially, uh, it's let me to control the game. And as you can see, this time I was a little bit better lucky. And again, I start talking and it's automatically intercept control. We'll see how it goes when I'm try to talk time. And obviously I'm lost again. So essentially, at least I demonstrate that potentially you can train the brain-computer interface to operate the environment. Um, at some point, you can actually use your mental commands to activate your avatar, like it's happening right now.